Today we are going to see how to learn data science in 2023. I am going to walk you through the complete roadmap, a step-by-step process and guide in how to become a data scientist. It is going to take around 5 months. And the best part, friends, is that zero money needed. All these resources are absolutely free. All you need to become a data scientist now is a computer, a laptop with an internet connection, and will to learn. If you have the willingness to learn and you're ready to put hours over here, I can promise you, I can assure you that you will become a very good data scientist and land a job of your dreams. Okay, so without further ado, let's start. The first and foremost thing, programming language. We all know that to become a good data scientist, you need to have some sort of expertise in a programming language. Now, friends, machine learning and data science can be done in a couple of programming languages. But what I would recommend is you to go just with Python. If you already have some experience in Python, good. If you do not have, then you need to build a solid foundation in Python. There is no going around it, right? It is very essential. Okay. Now the other language which is primarily used for data scientists or data science related job is R, but it is used much more in academic and research settings. Now you, me, all of us want to work and land into a good job in the industry. In the industry, the language which is being used is Python. Python is a beautiful full stack language. Okay, friends, if you're well versed in Python, if you have some experience in Python, very good. If you do not have any experience in Python, no problem. I've listed down all the topics which you need to cover to become it's a good Python when it comes to data science and machine learning. I've listed down the resources also. What are the topics which you need to cover? You need to cover first the introduction, and this is from the core Python. This is very much essential. So you need to know what is an IDE, what is Conda, what is a package manager. You need to know various IDEs. Now, there are a couple of IDEs which are popular in the market. I would only recommend two. If you are just starting up, there is nothing better than Jupyter Notebook. It's a beautiful IDE tool to learn machine learning concepts. Okay, and you should not go ahead with any other package manager apart from Conda. This is the industry standard as of today. Okay, there is one other IDE. I would recommend it for more experienced Python developer, that is VS Code. But if you are just starting, just stick to Jupyter Anaconda, and trust me, guys, you'll be all set. It has every capability to make your journey smooth. Okay. After that, you can go ahead and learn about syntax and semantics, the data structures which comes. These are pretty standard for any of the programming languages. If you have a background in other programming language, I'm sure that you will be able to pick up really fast. Then you learn about the functions, lambdas, what are list comprehensions, what are regular expressions, how to import files, how to read files, how to see this CPU related and OS related stats, right? So how to do the resource operations basically. Once you're familiar with this thing, you can jump straight away to the advanced Python. When I say advanced Python, these are the topics which are bare essential, which are very essential to make you a good data scientist. Data scientists, people use these packages day in and day out. NumPy, numerical Python, pandas is another package which you need to have a very good understanding. You need to deep dive into that. For visualization, I would recommend two particular packages, matplotlib and seaborn. I would recommend you learn both. If you are not able to learn at least one. If you are learning one, go ahead with matplotlib for visualizations. And then there are certain common modules and packages, right, which are being used, which you can learn. Now, there are two good resources which I'm listing down over here. The first one is the Corey Sheffer. It's a YouTube channel. He has 100 plus videos just on these topics. You go through these videos, you practice with the Jupyter notebook, and trust me, friends, you will have a very solid understanding after that, right? You spend a month time on this. Now the second is, again, I have also created a small playlist for introduction to Python. If time permits, you can go through that also and let me know that if you like it or not. Okay. Now let's move on. The next, the the, the two foundations on which data science or machine learning is standing is programming and maths, especially statistics, right? So we'll go ahead and we'll not devote, like we are not going to become a university professor in maths. What we are going to learn is bare essential maths, which will get us pushed to the next level in data science, right? What are those things? I would say there are four things which you have to learn. The first is the statistics. That is, there is no going around it, right? It is very, very essential. Everywhere, all the algorithms which we'll see, you will encounter statistics over there. Linear algebra, you should know about the concepts of the what are vectors, what are matrices, right? Calculus, differential calculus, not so much of integral calculus, but differential calculus. How if you are learning about the deep learning, or if you are doing the gradient descents, or you are doing the back propagation, everywhere you will encounter that, okay, you have to have a first level or second level of differential calculus needed over there. Probability is another thing which is needed, but go through the only very basic. I would say in probability, if you understand that what are the odds, what is the probability, and you go till naive Bayes theorem, right, of conditional probability. If you have learned till that, that should be okay. In calculus, differential calculus is okay. If you learn how to differentiate an equation or a function, first order, second order differential, perfect, fine. If you know what is a chain rule, what are the different other kind of rules in differential calculus, that should be enough. In linear algebra, learn about the vectors, matrices, learn about how a particular about the coordinate geometry, how a particular point is represented in a multidimensional space. Learn about how the matrix multiplication works, what is the difference between a dot product and a matrix multiplication. Learn those key concepts, basic concepts. In a statistics, you have to go a little deep over there. You may have to start with mean median mode. You have to know the central tendency, what is dispersion, what is standard deviation, what is variance. These are the basic concepts. Then you can move on to the different type of distribution, normal distribution, binomial distribution. Then you have to learn things about that, what is z test, p test, okay, and other type of distributions also you should learn. Then you should know about the hypothesis testing, A/B testing, ANOVA. You have to know, I would say, like 15 to 20 topics which are very much listed in in over here, right? I'm giving you the resources. Khan Academy, right, for probability and statistics, best resource. It's completely free. You can go ahead and learn it from there. Again, for the calculus also, I would recommend Khan Academy. Organic chemistry tutor, it's a very good YouTube channel. You should go over there, and if you are stuck in some concepts of statistics, you should go over there. The beauty of organic chemistry tutor is that he has given it in a question answer format, right? So you can practice as well, and you can enhance your knowledge over there. Once, I would say that don't devote more than 2 weeks over here for maths. Once maths is done, you can now progress to building your intuition around machine learning. I'm giving it 5 weeks over here. What are the things which you're learning? There are various steps in machine learning. Everything starts with the data ingestion. Once you start gathering the data and analyzing the data, that's where the machine learning starts, right? So the first and the very important part, exploratory data analysis, right? Exploratory data analysis, data pre-processing and analysis. Anything before you build the model consumes around 60 to 70% of a data scientist time, right? So devote good amount of time over here and learn these concepts. What are the things which you are going to learn about the data gathering? So data can be in a SQL database and NoSQL. What I would recommend you to is learn one SQL and one NoSQL database, right? So you can learn MySQL and Mongo. These are the two industry flavors which are going on. You can also learn how to gather data from CSV or JSON files. You should have some understanding how to connect to the, let's say, AWS S3 bucket, how to deal with the unstructured data like video, speech, text. There are certain APIs which are available for web scraping. Sometimes to gather the data, we have to scrape the internet, right? There are various APIs, how to code the API and get the data into our data sets, right? So those are the things which you will learn. After that comes the data pre-processing. Once you have gotten the data, you need to pre-process and analyze it. Now there are various steps in that, and all these steps are related to statistics which you already have built. So univariate, bivariate, multivariate analysis, correlation, causation, outlier detections, data cleansing. If there are null values present, what should be the way to cleanse the data? How should be the imputations be done? What is the dispersion and distribution? Again, after that, you move on to, before building the model, what you need to do is to split the data. You have to split the data into train, test, validation set. What are the various sampling techniques? And some core concepts, that how the bias and various trade-offs work, right? And how do you handle bias and various? For this, I would recommend, for this section, I would recommend a beautiful course which is on Coursera. It is in conjunction with IBM. Again, completely free over here. You should go this exploratory data analysis for machine learning, go through this course, and you will have a good understanding of all the concepts which I was trying to mention. Okay. Moving on, now you are hitting the real machine learning, where you have to learn the algorithms for the machine learning, the classical machine learning, what we say, right? So the machine learning landscape, machine learning end-to-end project lifecycle. What is regression? What is classification? What is supervised versus unsupervised learning? Batch versus online, and linear regression, multivariable linear regression, logistic regression. Now, friends, here I want to call one thing is that, so when you are learning machine learning, devote lot of time in the basics, right? So the basics are regression, and your one of the regression and classification problems, right? So logistic regression and linear regression, they are the ABCDs of your machine learning. They are the building blocks, right? So devote a good amount of time and have a very good understanding about a regression and a classification, right? So linear regression and logistic regression, learn it end to end. Okay, understand all the concepts. Okay, the later of the algorithms what is going to come will become much more easier. And at this moment, you should learn at least about scikit-learn. Okay, because the model building, all the model building which are going to happen will happen in scikit-learn. It's a module which is, again, you can download, you can install it in your Python, you can import it, and all the models will be built over here. Once you have done these basics, I would call these bases of machine learning. After that, to build a very good model, what you need to do is you jump on feature engineering and feature selection. Inside feature engineering, what is feature engineering? Like, you have got the data, but the data is not in the shape and cannot be sent to the model as it is, right? You need to do lot of processing, lot of engineering on that, right? Maybe you have to combine two attributes to get more insight. Maybe you have to split something. Maybe you have to encode something. Maybe you have to do other transformations, right? So that you can get better insight from the data. And there are various concepts in that. Feature selection. This is also very important. Nowadays, there are tons of features or attributes for any data, right? We are in the age of big data. What are the features which are important? What are the features which are not important? That comes under feature selections. There are different methods employed. I have listed down over there. Principal component analysis, dimensionality reduction techniques, multicollinearity, backward forward stepwise selection, lasso, filter wrapper, embedded method of feature selections, right? You have to learn these end to end. Now feature scaling. Sometimes the feature or the attributes what we are supplying to the model are not in the right scale. When I say right scale, that means, let's say feature A is in between 1 to million, and feature B is in between 0 to 1. Now they are not on the same scale. How can we bring them into the same scale so that our models can learn good insight from that and have good predictive power, right? That comes with a standardization and normalization. Over here, I cannot emphasize enough. Andre Ungs, he is, I think, is still the professor in Stanford. He is the founder of Coursera. He also is the founder of deeplearning.ai. He has a Coursera course. Now, this Coursera course is free to audit. What I mean by that is if you just want to learn and you do not want to get a certificate, it is free. But suppose you want to get a certificate, a credential, which you want to put it on LinkedIn also, it is paid. Okay. So I leave it up to you. If you want to just gain the knowledge and do not want to or do not have the money to spend on it, do not spend. Just go on Coursera, do the audit, and you should be able to see all the lessons, all the videos over there from Andrea. Very, very good. All the concepts which I'm trying to tell above are already discussed in great detail over here. Now, another YouTube channel I would recommend is whenever you are stuck on some algorithms or concepts and you are not able to go forward, look into this beautiful YouTube channel, Josh Starmer, right? He runs a StatQuest YouTube channel. Go over there and learn those concepts. These are 5-minute, 10-minute videos, but they will give you a very good understanding. Once this is done, we can move on to advanced machine learning. Here we are going to learn all the algorithms, right? Naive Bayes, KNN, support vector machines, the various ensemble techniques, right? What is bagging, what is boosting, what is random forest. Then on top of that, once we have learned all these, we learn that, okay, we have built the model, but is the model good or not? How can we select the model? How can we tune the model? Then there is hyperparameter tuning, right? All those you learn about it, right? This is essentially that you have got the model, but how can you make it better? How can you have more predictive power built into that model, right? So this is improving the model. Okay, this is stage. So model performance, how do we measure the performance? What is the bias and variance? We have already discussed this. Overfitting and underfitting, what is cross validation, grid search versus randomized search, regularization, pipelining. All these techniques are falling under the supervised learning, right? Then there is another branch of machine learning, which is unsupervised learning. This is around clustering. So you learn all the clustering techniques also over here. These are the various algorithms, 6 or 7. You learn all these, that should be enough. Okay. Then what I would recommend you to do is to spend some time, at least if you are starting, spend some time in production deployment. Building model is not enough. People are going to ask you question in interviews that, hey, you have built the model, it is in the Jupyter notebook or in a Python code. How do we deploy into production? How can we make an app out of it? If you have to do, and those questions will be asked in the interviews, if you want to do that, then you have to learn about these, right? So what I would recommend is that Flask is a very good framework. You can build inside that. Heroku, you can do that. Now it is no longer free. Fast API you can use. You can do the deployment. Okay. So there are various mechanisms. You try to do these deployments. There are various resources which I have listed down below. Okay, around that. Now for the advanced machine learning, what I would recommend is a couple of courses. One is the Stanford CS229. This is the whole course is put into the YouTube playlist, right? You can go over there and this will give you a very good understanding, right, from one of the best minds in machine learning. You learn from them. Kaggle is another good resource, right? So Kaggle is not just for the data sets. I'm going to talk about Kaggle in just in a minute. A data scientist cannot live without Kaggle. It's not just for the data set, but for learning also. So there are good tutorials. You can make use of it. It is also completely free. Once you have done that, we come to the deep learning part. Now, deep learning, I have devoted 5 weeks. I know that it is very short. Deep learning is a vast, expanding field now. Even the research is going on. So it's a never ending. But to build a foundational understanding, I think 5 weeks should be enough. What you need to do, you need to have the basics of deep learning. What is the neural network? What is the perceptron? How the loss function activations is, what is gradient descent, batch normalization, the basics of TensorFlow and Keras. Keras is the high-level API built on top of TensorFlow. What is transfer learning and regularization when it comes to deep learning, right? You need to know these basic concepts. Once you have brushed that up, you need to know two things. One is on the computer vision side, especially on the video and the photo side, right? You need to know convolutional neural network, CNN, okay, and everything related to that, semantic segmentation, object detection. These are very, very niche new areas where a lot of research are happening. After that, you need to go to RNNs, the recurrent neural network. All the sequence related data, speech, NLP, everything falls in RNN, right? So whatever we see around chat GPT or GPT or generative models, right? Everything you will learn over here. Okay, now there will be some advanced concepts and you may have to take little bit of time. If you are not able to complete, that's fine. So autoencoders and generative adversarial network GANs, if you are not able to complete this section, that's fine. Okay, don't worry about it. If you are able to convert or if you are able to learn completely CNN RNN and practice it, that should be good enough for you to crack the interviews. If the time permits, over here again, friends, I'm saying 5 weeks is not that huge, right? If the time permits, you can go and learn about the reinforcement learning also, right? Now, what are the courses which I would recommend over here? Andrew Ng's CS230, a Stanford course. He used to teach in Stanford in CS230 course. The whole course is put on the YouTube. I have linked it over here. Again, Coursera deeplearning.ai course. Here the deep learning courses are, the whole deep learning course. Again, I am saying for audit, it's free. But if you want to take a certification, if you want to display it in your LinkedIn profile, you need to pay. It's a couple of thousands, I think. But if you, I think there is a merit. If you can afford that, go ahead, pay it and take the course. If you are not, just audit it, learn it, and forget about it. Okay. Another course is from MIT 6S 191. This is also a very good. I think these are like 8 lectures of 1 hour each. Very good understanding of deep learning you will get from there. Another one is CS231N. This was taught by Andres Karpathy. I really, really respect that guy. He's the genius when it comes to the AI field. Okay, this is the course which is built by him, and the entire course is on YouTube. Okay, Google machine learning course also you can see. If you are able to see the ones which I am saying over here, if you are able to go through, trust me, you'll have a very good understanding of deep learning. Okay, now towards the end, I would say that there are few books which I would recommend. Now, these books, if you see the prices in India, they are costly. If you can afford, I would highly recommend you to go ahead and get a printed copy so that you can browse through it and learn from it. But if you are not, I'm not going to link those links over here, but I know you know how to search Google and get a PDF copy. Okay. So all these PDF copies are available, but you have to Google yourself and get it. The first book I'm recommending is Practical Statistics for Data Scientists. Very good. If you are building a statistical knowledge, all the statistical concepts are listed down over here. The second one is from Aurélien Guérin, The Hands-on Machine Learning and Cycle. This is like a Bible for machine learning engineers, right? If this is end-to-end machine learning captured beautifully, this is the person who was the scientist at YouTube, right, and had written all the recommendation engines for YouTube. Now the third book I am recommending is especially for deep learning, right? So this is again from the, if you see the Ian Goodfellow, right, and Yoshua Bengio, right? These are the founders of multiple algorithms in deep learning, right? The book is written by them itself, right? So very good book. Again, these are very pricey in India. If you are not able to afford, no problem. Go into the internet, search for a PDF copy, and you'll get a PDF copy. I have not linked it because of the I don't think it's very ethical to link those links over here, right? Okay, you have seen the courses, you have seen the books. Now the couple of podcasts, if you are taking a morning walk or you are going through the commute and you want to listen to something, I would recommend two podcasts. Lex Friedman podcast, he's a professor in MIT over here. Andres Karpathy, I was again saying that he's a beautiful mind. I totally respect it. It's not a podcast, but a YouTube channel. He does tinker with the code, and he gives tutorial. So it's not a podcast, but it's a tutorial sort of video. But you should definitely see. He was the director of at OpenAI. He was the director of self-driving cars, autonomous cars at Tesla, very recently. So he has done great work. You should definitely subscribe to his YouTube channel. Okay, before I end, a few things. Learning is one thing, friends. but you need to have, what you need to do is these four things as well. One is you have to have, you need to practice, practice, and practice, right? Let me start with this. There is no shying away from practice. If you are just watching the video, the retention will be very, very low. Trust me. If you have to practice, you open your Jupyter notebook and you start writing code. You start practicing. Once you practice, once you tinker, then you will learn. Okay. The second thing is the number one over here. Build at least 3 end-to-end project portfolio. Now, to get the idea of that what project you should be doing, you go to the Kaggle. Don't look at the basic Titanic and Iris data sets that have been done to death. Don't build on top of it, right? Find a use case, find a scenario from your common life, find a scenario from your work, okay, whatever, and then start building those portfolios, right? You can build one in the deep learning space, one in the classical or the basic machine learning space, one's in the advanced machine learning space. You can take three, or you take three from separate domains also. Comment me if you want me to tell you that what are the, you can reach out to me if you want to get the ideas of what are the different machine learning projects which you should be doing, okay? But do your own research. What I really want you to do is to that you should build 3 projects end to end, and you should put it on Kaggle, okay? You should link it on, publish it on LinkedIn also. You should clearly show that what are the novel or the new things which you have done over here which has not been done previously, or which not many people have done, right? That will showcase your expertise. The second thing is build an online presence on LinkedIn by posting and engaging with other ML community members. So this is very important. LinkedIn is the new resume. No recruiter is looking at the resume nowadays. The first thing they are doing is they are going and fetching for your LinkedIn profile. So spend some time in building the LinkedIn profile, and then engage with the other, follow other community members, ML community members, learn from them, right? You'll get a lot of good news, good ideas from there also. I've already discussed practice, practice, and practice. If you do not put a hard work over there, all these things are going in vain, right? There is no use of it. If you work hard, practice hard, I'm sure that you will be able to crack interviews. The fourth and the last thing, learn from others, especially Kaggle notebooks. You go to Kaggle, you see the challenges. Don't participate in challenges, but see what other people are doing through their notebooks. Okay, you learn a hell lot from there. Okay. So with that being said, I hope this was useful to you, and you'll make use of it. If you have any question around this, do let me in the comment section. I'm going to upload this on the GitHub and link it in the description. Okay. With that being said, thank you so much, and I'll see you all in the next video. Bye.